This is lesson for 13-4. I can solve a system of equations. All right. You're going to be given one linear equation, so one line, and one quadratic equation, so one parabola. So you're going to be doing these both graphically and algebraically. Sometimes you're going to get graphs that look like this, where you have two intersection points. You have one here and one here. You're going to have to find the coordinates of both of those points. Remember that coordinates of points are written x, comma, y. Remember that your x value is how many you go over, and your y value is how many you go up or down. And I have no idea what's wrong with this mouse. It's really, really acting weird. For one intersection point, you're going to have your line and then your parabola, and it's only going to cross in one point. It just sort of touches it in one segment and bounces off of it. Then you're going to have some that have no intersection point, where the line and the parabola don't cross. When that happens, you're going to write no solution. And in Class Kick today, you'll actually type in the words no solution when they don't cross. So some are going to have two solutions, some will have one solution, some will have no solution. So let's talk about how to do this graphically first. All right. When you go to do this graphically, notice these are the two equations that we're using. All right. We have y equals 2x plus 7 and y equals x squared plus 4. What you want to do is you want to type both of those equations into your y equals. So hit y equals and type in this first equation, 2x plus 7. I know it's been a while since we graphed anything. Remember, the x button is up next to the alpha button, next to that green button. And then we want to tab down and we want to graph the other equation right away as well. So we want to type in x squared plus 4. So those are our two equations. We want to use the table feature to plot the points. Now, if you wanted to get a sneak peek at what it's going to look like, all right, it's going to look like that. Now, this graph doesn't really help us out much. All right. If I was doing this question, I would hit the zoom and then out, just to be able to see where they actually cross. So I can see on my graph that they are crossing in two spots. All right. So we want to use the table to plot the points. So second button, and then remember your table button is in that upper right-hand corner. So second and table, and we're given the coordinates. Now it does both equations at the same time. So you just have to plot one and plot the other. Let's plot the line first. So we have the point 0, 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to put a point here. We have 1, 9 over to 1 up to 9. We have 2 and 11 over to 2 up to 11. We have 3 and 13. And we have 4 and 15. That's way more than enough. All right, that's way more than enough. Just make sure that you get a nice straight line. If you want to work backwards, you can. Remember, we could tab up using the arrow pad to find out some other points like -1 and 5 and 0, or -2 and 3 and -3 and 1. So we could get those points if we really wanted to. Connect the dots to form your line. Put your arrows, and always make sure that you label your lines. On the Regents exam, they are very, very picky. If you do not put arrows, if you do not label, they take off points. So always make sure that you label your lines. Switching over to the parabola. All right, switching over to the parabola, we have -3 and 13. So over to -3, 1, 2, 3, up to +13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have that point. I have -2 and 8. 1, 2, 3, 4, 5, 6, 7, 8. I have -1 and 5. I have 0 and 4. over 0 up to 4. I have 1 and 5. I have 2 and 8. I have 3 and 13. So there's my points in the red. All right, we want to connect them to form a parabola. Remember, a parabola is a U-shaped graph. Make sure that you put arrows on the ends again, and make sure that you always label your graph. So that's what our graph looks like. We want to write the solution to this. The solution is where they cross. All right, the solution is where the line and the parabola cross. So we're looking at this point right here, and we're looking at this point right here. Now, one of the sort of cheater ways that you could see where they cross is if you look at the table. Notice that this 5 and this 5 are exactly the same right here. All right, we have this 5 and this 5. That tells you that that's the same exact point. All right. The other place where they're the same is the 13 and 13. So one of the ways that you could tell the intersection point is by looking at the table. And if you do them at the same time, like I did, those numbers will be the same. So I know that one of the points is -1, 5. And the other point is 3, 13. I can tell that because on the table, it's the same. I could also look at the graph. All right. When I look at the graph, -1, 5 over to -1 up to 5. All right. My blue line was a little bit high when I drew it. And 3, 13 over to 3 up to 13. I can see that they cross right there. A third way that you could tell exactly where the intersection point is this part right here. I could go on my calculator, hit second and calc. Calc is right here next to the graph button, which is your trace button. Go down to number 5, which is your intersection point. And remember, it's going to ask you first curve and second curve. So they want to know, is this little blinky thing on the first line that you want to use? Yes, it is. So I'm going to hit enter. Is this little blinky thing on the second thing that you want to use? Yes, it is. It jumped over to the red. And now it says guess. Now, the reason that it says guess is because it's 2 intersection points. If I want this one over to the left-hand side, I want to keep the blinky thing more closer to that. So if I hit enter a third time, notice that it says the intersection point is -1, 5, all right, which is exactly what we got here. If I want to find the other intersection point, I can go through that same process. Second calc, number 5 for the intersection point. Is this on the first line that I want to use? Yes, it is. It's on the blue line. Is this line, is the blinky thing on the red line? Yes, it is. But now when you get to guess, I would want to move the little blinky thing closer to the other intersection point. If I do that and hit enter, notice that now, because my guess was closer to the one on the right-hand side, notice that now it gave me the other intersection point of 3, 13. So there's 3 different ways that you can find the intersection point. Whichever way that you want to do it, you can do it. All right. Probably the safest way is to do it on the calculator, how I just did it, using second calc and then number 5. So that's solving it graphically. What you will have to do on your homework is you will have to graph it like this. All right. You'll have to graph it on a graph like that. So solving algebraically. Solving algebraically is a little bit more complicated. All right. What you want to do is you want to set your 2 equations equal to each other first. So notice that they're both in the y equals form. So we want to set these 2 things equal to each other. And you will have to show this work in class kick today. So when you set them equal to each other, normally if this was just another line, we could just solve that equation. But because it's like this, what we want to do is we want to set one side equal to 0. We're still using things. We're still using that quadratic formula that we used in the last chapter. So we want to get it set equal to 0. To get it set equal to 0, you never want to have a negative x squared. So what I'm going to do first is subtract 2x from both sides. Now notice that I put that in the middle so that it stays in that standard form. And then I'm going to subtract 7 from both sides as well. That way those cancel out and those cancel out. So I now have 0 equals x squared minus 2x. 4 minus 7 is -3. Now it looks like something that I can solve for x. Think back to the last chapter. Notice the next bullet says solve for x using any method. There are 3 different methods that you could use. You could, if you wanted to, you could factor and figure out what times what is the last number that adds up to the middle number. Once you get what's inside the parentheses, draw your line down the middle and solve for x. You can do it that way if you want to. So if I wanted to do it that way, I would go and say what times what is -3 that adds up to -2. Well, that is -3 and +1. -3 times 1 is -3. -3 plus 1 is -2. Draw my line down the middle and solve for x. So I would do x minus 3 equals 0. X plus 1 equals 0. Solve for x, so +3 plus 3, minus 1 minus 1. Those cancel out, those cancel out. I get x equals 3, and I get x equals -1. That's one way that I could do it. A second way that you could do it is you could complete the square. Now, I would not suggest doing it by completing the square. I think that's the hardest way to personally do it. So I'm not going to do it that way at all, although you could do it. The third way is the quadratic formula. That quadratic formula is used for a lot. We could use it right here to this equation. So I have -b plus or minus the square root of b squared minus 4ac all over 2a. So -b, this is my a, this is my b, this is my c. I could do -b, so negative of -2, plus or minus the square root of b squared, -2 squared, minus 4 times a times c, all over 2 times a, 2 times 1. Negative of -2 is +2, plus or minus. When you do this calculation inside the square root, you get 16. So plus or minus the square root of 16 over 2. 16 is a perfect square. 16 is just 4. So I now really have 2 plus or minus 4 all over 2. Take and split that into 2. So I have 2 plus 4 over 2, and I have 2 minus 4 over 2. 2 plus 4 is 6. 6 divided by 2 is 3. 2 minus 4 is -2. -2 divided by +2 is -1. Notice that I got the same exact answer as factoring with the 2 sets of parentheses. It does not matter which method you use. If you really like using the quadratic formula, I think that's probably the easiest way. That's just my personal opinion. I don't like having to come up with what times what that adds up to what, especially when you have a number that's not 1 as your a value. I like personally using the quadratic formula all the time. I just think it's easier. It's right to the point, and you get your 2 answers. Here's the thing. Notice that our answers are not complete yet. Notice that we only found x, all right? We only found x. Well, how the heck do you find y? Well, what you have to do to find your y value is you have to choose either equation. Now, which equation looks easier to use probably? Probably the y equals 2x. So what you're going to have to do with that y equals 2x plus 7 is you have to sub these numbers back in to x to find your y. So you're going to have to do two separate calculations. Using the 3 first, I would have 2 times 3 plus 7. 2 times 3 is 6. 6 plus 7 is 13. So my one answer is 3, 13. My other answer, when I go to sub in the -1, I would have 2 times -1 plus 7. 2 times -1 is -2, plus 7 is 5. So I get -1, 5. That's my second answer. Now, notice that we use the same equations. We did it graphically over here and got -1,5 and 313. We did it algebraically over here and got the same answers, -1,5 and 313. You do not have to do it both ways. You don't have to do the factoring and the quadratic formula. Just pick one or the other. All right, it does not matter. So that's what you're going to have to do for every single question. All right, take a look at the next one. In this next one, these are how the homework questions look like. It says solve the systems of equations algebraically and graphically. So let's do it graphically first. All right, let's do it graphically first. So let's go back to y equals. Let's clear out these equations. So we have -2x plus 4. And we have 4x squared plus 2x plus 5. Okay. So when we go to graph it, it looks like that. All right. If I zoom in a little bit, you might be able to see it a little bit better. Notice that in this one, it looks like it's only touching in one place. All right. Notice that it only looks like it's touching in one place. Can I find the intersection point of that? Sure. Remember that you can go to second and table to find the points. And you're looking for where the two numbers are the same. Now, notice that you don't see any numbers that are the same. That's because in this one, where they cross, the x value is actually going to be a decimal this time. All right. So that's not going to be very user-friendly with that. But we can still graph it from using the table. All right. We can still graph it from using the table. So go ahead and go like this. So looking at our line, -2x plus 4, -3 is 10. So over to -3, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -2, 8. -1, 6. 0, 4. And we keep on going on with that same pattern. So I get a line that looks like this. For my graph of my parabola, that's in the red here. 35 is too high. 17 is actually too high as well. -1, 7 over to -1, up 1, 2, 3, 4, 5, 6, 7 is right here. 0, 5, 1, 2, 3, 4, 5. 1 and 11. Over to 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So those are the only points that really fit there. I know from looking at it, it looks like this. That's why it's always good to hit that graph button and see what it actually looks like. These are going to touch right in here. All right, they're going to touch right in there. Where are they actually going to touch? I should label my line. Where exactly do they cross? If we go to graph, second, and calc, go down to number 5, intersection point. Is that on the first line? Yes, it is. It now jumped to the red line, so it equals again, guess. So notice that the intersection point is negative 0.5 and 5. Just ignore anytime that it has like 0.00000, just ignore all those zeros. It's just 5. All right, that's just a rounding thing. So now I got to do it graphically. I know that that's going to be my answer though. I know that my answer for X when I do my quadratic formula should be that. I know that my answer for Y should be that. So the first thing that you want to do is set these two equal to each other. We want to set everything equal to 0. I want that X squared to stay positive. So I'm going to do plus 2X and plus 2X. I'm going to get rid of that plus 4 by doing minus 4 and minus 4. We want to set it equal to 0. So now 0 equals 4x squared plus 4x plus 1. You could do completing the square. You could factor it. I don't like the idea of either of those because of the 4 as an a value. I'd rather use the quadratic formula. I just think that it's easier. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This is why it helps to memorize that formula. You don't have to look it up every time. Just go step by step by step. So negative 4 plus or minus, when you do 4 squared minus 4 times 1, you get, you actually get 0. All right. So plus or minus 0 over 8. It would be the square root of 0, but the square root of 0 is just 0. Adding 0 to something, subtracting 0 to something does essentially the same thing. Nothing really changes. So I could, if I wanted to, I could split it and do that. It probably looks nicer if you do it this way, but you don't have to do it this way because adding and subtracting 0 to something does essentially the same thing. Either way, we end up with negative 4 over 8. Negative 4 divided by 8 is negative 0.5. Notice that we got the same answer for both of them. We got negative 0.5 and negative 0.5. We got the same answer for both of them because there's only one solution, right? There's only one solution on this one. To get your Y value, we have to sub it back in. So we need to take it and sub it into here in the equation. So Y equals negative 2 times negative 0.5 plus 4. Negative 2 times negative 0.5 is 1. 1 plus 4 gives you Y equals 5. So notice that we got the correct X value, we got the correct Y value, exactly what matches to how we did it correct. These are a pain in the butt, aren't they? One last one, because we got to do one that has no solution. All right, this one's going to have no solution. So let's take a look at what the no solution looks like. So let's graph it first. So let's delete this one and have negative 4x minus 7. Go down here and we have 3x squared plus x minus 3. And we hit graph. Notice that these two do not cross at all. They do not touch. Therefore, I know that my answer is going to be no solution because they do not cross at all. So if we want to graph them and you go to second and table, all right, these axes will be drawn for you already in class kit today. So taking a look at this one, I have negative 3 and 5. Right, negative 3 and 5 over to negative 3, up 1, 2, 3, 4, 5. I have negative 2 and 1. I have negative 1, or sorry, I have negative 2 and 1. I have negative 1 and negative 3. So I'm forming this line right here. And then for the parabola, I have negative 2 and 7. I have negative 1 and negative 1. I have 0 and negative 3. I have 1 and 1. And I have 2 and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I basically have this parabola working here. So that's what it looks like graphically. Notice that they don't touch at all. I'm going to set these two things equal to each other. Now this one's actually going to be easier to solve because it's going to be no solution. So the first step is still the same. We want to get everything equal to 0. So plus 4x plus 4x and plus 7 plus 7. Those cancel out, those cancel out. So we have 0 equals 3x squared plus 5x plus 4. I want to use the quadratic formula. Now, again, you could do the factoring with the 2 sets of parentheses and stuff like that, but I would just stick with the quadratic formula. It's just easier. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Well, here's where it gets pretty easy because when you type in 5 squared minus 4 times 3 times 4, you end up with a square root of a negative 23. You know from the previous chapter that anytime that you end up with this negative of square root, it is automatically no solution. You can't take the square root of a negative number, so you can't do anything further. You can't go any farther than that because you have a negative of a square or a square root of a negative number. Because that's an imaginary number, it is no solution.